We are going to be using some quadratic techniques to solve polynomial equations, and some of these techniques you already know, and there'll be a few that are new to you. So just like we've done in the past, we're going to be factoring this polynomial because we want to find out what the zeros are, or the roots, or the x-intercepts, where they cross the x-axis, which make them 0. So we need to factor this, set them to equal to 0, and solve them, and that tells us where they're going to cross the x-axis. Those are our zeros. Now, if they have an imaginary number, then those won't be crossing the x-axis, but they could be zeros. So the first thing I look here is that my polynomial, everything's on one side, and it's set equal to 0. If it's not set equal to 0, you have to do that. So I look at it, and I see that they all have an x squared in common. So I'm going to factor out an x squared. Alright, so I factored out an x squared, and now I'm going to look at the x squared plus 3x minus 18 and see if that is factorable. And yes, it is. So I know that there's a coefficient there of 1. So I need to multiply to figure out that times that is negative 18. And then, so I'm looking for factors of negative 18 but add up to 3. Alright, so all of the factors of negative 18, I found out that 6 and negative 3 multiplied together give me negative 18, but add up to 3. So that is the factored form of the x squared plus 3x minus 18. So now I've put all of these factors, set equal to 0, and solve them. Alright, so you can see I've set each one of the factors set equal to 0. So from here then, all of these are my zeros of my polynomial, meaning they are my roots, and that's where they cross the x-axis on there. So if I were to graph that then, my graph would look like something like that. So that would be negative 6, 0, and 3. Alright, so this will be a new one. So this is x to the 2/3 minus 8x to the 3rd plus 15 equals 0. So everything's set on one side, so it's equal to 0. Since we're using a quadratic technique, that means we want something to the second power. So we're going to have x to the 1/3 to the second power. Because if I would take x to the 3rd, square it, I'd get x to the 2/3. So really, you're just taking the numerator of the 2 and putting it on the outside, and then you have 1/3. And then you just write the rest of it. 8x to the 3rd plus 15 equals 0. So once again, I want factors of 15, positive 15, but add up to negative 8. Well, I know that would be negative 5 and negative 3, so then we would write it as x to the 1/3 minus 5 and x to the 1/3 minus 3 equals 0. So that's what that is factored, the x 1/3 squared minus 8x to the 3rd plus 15. That's what this is factored. So really I just bring down the x to the 1/3 in both spots, here and here, and then I find the factors of 15 but add up to negative 8, and that's what I have there. So now I set each one of those factors equal to 0, and now I need to solve that. So in order to get rid of the 1/3, well, first of all, I got to put the 5 on the other side, so I have x to the 3rd equals 5. So I just added 5 to both sides. Now in order to get rid of the 1/3, that's like the cubed root. So really it looks like kind of like this, the cubed root of x. And what can you do to get rid of the cubed root? Well, I can cube it. So that's what we're going to be doing there. So the 1/3 power, same thing as a cubed root. So I'm going to cube it, and I have to cube this side. So the 1/3 and the cube to 3 power, they cancel out. So I have x equals, and 5 to the 3rd power is 125. So there's one of my answers. Alright, so I go to the next one, and I put the negative 3, I add 3 to both sides, so I get the 3 on the other side. And again, since I have 3rd power, I'm going to cube it. If it was the 1/4, I'd take it to the 4th power. If it was 1/2, I'd square it. If it was 1/5, I'd take it to the 5th power. Alright, those cancel out, so I have x equals 3 to the third power is 27. So those are my zeros, those are my roots, that's where they cross the x-axis. So that is my answer. So now I have x minus 8 square root of x plus 7 equals 0. So it's already set equal to 0, so I don't have to worry about that. So this is a new one here. And the first thing I'm going to do when I have something that looks like this, I'm going to look at my a term, which is the coefficient there, so that equals 1. B equals negative 8, and C equals 7. And for this one then, I'm going to take the square root of x and then square it, because if you remember, if I take the square root of a number and square it, the square root and the square cancel each other out. If it was a cubed root, then I would cube it, take the third power, those cancel out, then just write the rest of it there. So really that square root of x squared kind of cancels out, so really I didn't do anything. It still represents just x there. Now this is, since we have the square root in there, we have to use the quadratic formula, and that looks like this. So there's the quadratic formula, but since we have the square root, this time it's going to have the square root, and you'll see what I do with that in there. So I still use the quadratic formula like I normally do, but when I get to the very end, I have to do something with that square root. So I'm going to take my negative 1, my 1, negative 8, and 7, substitute those in for the a, b, and c, and solve for my quadratic formula. Alright, so you can see I've substituted my a, b, and c in my quadratic formula, and now I'm just going to solve for it. So I had negative, negative 8. Remember, there's two negatives because one comes with the equation, negative b, but my b is negative 8, so that's why I have negative, negative 8. So now I'm just going to solve it. Alright, so you can see my steps down there. I've solved it, so you can stop the video if you need to see what I did. I just did the quadratic formula just like you always have. So now I have 8 plus 6 over 2, which is going to be 14 over 2, which is going to be 7. And I also have 8 minus 2, which is, 8 minus 6, which is 4. 8 minus 6, which is 2 over 2, which is 1. Now I have to go back and use that square root. So I have square root of x equals 7, and the square root of x equals 1. So to do that then, I square it. So I have to square this, square it, because the squaring gets rid of the square root. And so 7 squared is 49. And 1 squared is 1. So those are my answers. Those are my zeros. Those are my roots then. Alright, our last problem is x cubed minus 216 equals 0. So everything's already on one side, set equal to 0. And since it's a cubed root, this one is going to be factored in the form of a minus b times a squared plus ab plus b squared. So, x cubed minus, x cubed that is, minus 216, I want to write that as a cube. Something times itself 3 times. Well, that would be 6 cubed. That's the same thing as 216. So that's what I'm going to use to factor this in. So my x is my a, and my 6 is my b. So I'm going to substitute those in my equation, and then I'm going to factor it. Alright, so you can see in the red that I put, for wherever I saw an a, I put an x, and whenever I had a b, I put a 6 in there. So my next step is to see if the x squared plus 6x plus 36 is factorable. So I look to see if there is some factors that times that. So coefficient there's 1 times 36 is 36. So I need factors of 36 but add up to 6. Well, there is no factors of 36 that add up to 6. So I'm going to have to use the quadratic formula on this one here. So I have 2 factors right now. I have this factor and this one here. This is another factor, but I can't factor any further. I have to use quadratic formula to find out those zeros to factor it there. So I have x minus 6 equals 0, so x equals 6. So there's one of my answers. Now I'm going to use a quadratic formula to find the other one here, which is, I'm underlining here in blue. So I'm going to use the quadratic formula to find the other answers. Alright, so you can see I substituted the A, B, and C into my problem, the quadratic formula. So you can go back if you need to see what the quadratic formula is. And so now I'm just going to solve it. So I have negative 6 plus or minus, and 6 squared was 36, and 4 times 1 times 36 is 144, all over 2. And I'm going to go to the next slide to give me some room to solve this. Alright, so I got negative 6 plus or minus the square root of negative 108, because that's what 36 minus 144 all over 2 is. So I have a negative 108, so that means I have to take the negative out, so that becomes my imaginary number, square root of 108, all over 2. So I have negative 6 plus or minus imaginary, the I, and I know the square root of 108 can be made up to square root of 36 times the square root of 3, because 36 times 3 is 108. So I found the factors of 108, and then I separate them there, all over 2. So then I have negative 6 plus or minus I. 6 square root of 36 is 6, square root of 3, all over 2. So now I have negative 6 plus or minus 6I square root of 3, all over 2. Now this can even be simplified further, because these two can be simplified to negative 3. So I'd have negative 3 plus or minus, and then also these can be separated into, simplified down to 3I square root of 3. So my final answer would be negative 3 plus 3I square root of 3 and negative 3 minus 3I square root of 3. So those would be my two answers, and I already had one from before on the other slide, which was x equals 6. So there's my 3. And I knew I was going to have 3 because if you look back at the original problem, this exponent on the x is a 3, so that means I'm going to have 3 factors. And just like back here, let's go to this one, the first one, the 4th power. So then I have 4. It only looks like I have 3, but I really have 4 because 0 would be plus 0 and minus 0, but that doesn't change anything on there. So, and I think this one, whoops, sorry about that. This graph is wrong, so ignore that, because it's to the 4th power, so it's going to be something like that, or something like that. It's going to be a quartic, so it's going to cross 4 times up there. So, but anyway, so take your time on the lesson, look at the examples, stop it, rewind it, and see what I did, and good luck to you.